The second digit of the VSEPR number is the total number of bonding domains around the central atom. Once again, the domains around the other atoms are not relevant. This means that the number of single, double, or triple bonds. Remember, double and triple bonds only count as one domain. So circle and count the relevant bonding domains in each of the below, and then go to the next slide when you're ready for the answers. We're looking for the number of single, double, or triple bonds around the central atom. And double and triple bonds only count as one domain. So that's going to be our second digit here, 3, right? 1, 2, 3. In this case, for the fluorine and the xenon, it's 1, 2, 3, 4. You can see the 4 there. And then finally, for these 3 oxygens here, 1, 2, 2 bonding domains. The third digit of the VSEPR number is the total number of lone pairs, and once again, around the central atom. You can check your work. The first digit is always equal to the sum of the second and third. So here's an exercise. Circle and count the relevant lone pair domains at each example below, and the answer will be on the next slide. So we're looking for the number of lone pairs around the central atom, and that will be the third digit, which is bolded here in each case. So for this molecule, 0. And then check your work. 3 is equal to 3 plus 0. For your xenon fluoride here, you have 2 right over here and here. And look how the number 2 and the number 3 places, add them together, you get the first one, which is 6. And then finally for this O3 molecule, you have 1 lone pair here, so you get a 1, and 1 plus 2 is equal to 3, so it all checks out. Now that you have the 3-digit VSEPR number for each molecule, use the chart to determine their shapes. So you have your 3 digits number here. You want to look over in this column, and then move over to the right to find the shape. The answer will be on the next slide. So our 330 is a trigonal planar right over here. 642 down here, that's a square planar, which looks like this. And then finally 321 is bent. There is only one molecular geometry for 2 atoms and or lone pairs around a central atom, and that is linear molecular geometry 220, and we have that 180-degree angle there. There are 2 molecular geometries for 3 atoms and or lone pairs around a central atom. First we have trigonal planar, if all the electron domains are bonding, and that would be a 330. Bent, if one of the domains is a non-bonding pair, which is a 321. Unbonded pairs of electrons repel more strongly than bonded electrons, thereby shrinking the bond angle between atoms. We have 3 molecular geometries when you have 4 atoms and or lone pairs around a central atom. The first is tetrahedral, if all are bonding pairs, and that's a 440. The second is trigonal pyramidal, if one is a non-bonding pair, 431. And then a bent, if there are 2 non-bonding pairs, which is a 422. There are 4 molecular geometries when you have 5 atoms and or lone pairs around a central atom. The first is trigonal bipyramidal, which is a 550. Then we have seesaw, which is 541. And notice how the second 2 numbers add up to the first one. That's a good way to check that you've got the right designation there. Then we have a T-shape, which is 532. And finally, linear, which is a 523. There are only 3 molecular geometries for 6 atoms and or lone pairs around a central atom, and that's called octahedral molecular geometry. We have the octahedral right here, which is a 660, square pyramidal, which is a 651, and finally square planar, which is a 642.